this 1/2 add x cubed, right? What else do we have?
Plus 1/2 t add y at x squared.
1/2 t add, what do you say, add y? Where'd the half come from?
You're doing it with 1/2 at x squared, right?
Oh, that one?
Yeah.
Yeah, okay, cool. Is there anything else cubic?
1/2 t squared add y squared times add x.
Yeah.
Okay.
1/2 t squared add y squared times add x. I think that's it.
Yeah, yeah. All right. And while we're at it, what's the best of z minus 1 cubed? We're just looking for, you know,
It's gonna be x cubed.
so we can just multiply this
Yeah.
by that, I believe.
So we have at x cubed. Plus t add x add y add x.
Add x, add y, add x, like that.
Yeah, I think you got a t as well.
T add y add x squared. We're just looking for third order?
We're just looking for the third order terms in z minus 1 cubed, which
I think that's
do not end. They only end with add x. They can have add y in them, but not at the end.
Yeah, I think that's
yeah, I don't see anything else that's third order or less.
Okay, good. Thank you, guys. All right, trusting you. All right, so what do we have else? Now we go back to here. So far, we've only taken care of this guy, right? That's all that's in there. Once you hit it with y, that's all that survives, right?
Right.
So if we look at z minus 1 squared, with the y, what do we pick up?
Ooh, I think there's one more.
Which one? Where? Which one? Best of? Which best of?
The best of z minus 1 cubed. You have a t squared add y squared add x.
Any factor out front, or just t squared?
It's the t add y times t add y add x term.
So that,
Where's
where's the add x?
So it's the second one of both multiplied times each other. So the second one of z minus 1 and the second one of z minus 1 squared.
Oh yeah, that's right.
That gives you a term as
So
well.
this times that?
Yeah.
Yeah, well that times.
Okay, so it would give me, right, so
t
be
squared add y
t squared add y
t squared add, okay, plus, yeah, t squared add y squared add x.
Yeah, and that's everything.
Okay.
Good job, Brad.
Wait, what's
I
that?
said good job.
Oh, yes, good job. Yes. Indeed. All right, so minus 1/6. Okay. And then what?
Didn't actually pick all that up on the
X.
Did what?
all the stuff to the right I didn't actually quite get.
Uh-oh. Can you get it now?
Let me zoom in on it real quick, and then yeah. Okay, we're good.
All right. So let's see here. We're looking at the z minus 1 squared, and we're hitting it with the y. So we got what? We got ourselves like
Commutator of x with commutator of xy.
then.
Plus t commutator of y with xy.
That's it. Oh yeah, to second order. Thank you. Yeah, everything past here has got 3 or more. All right. So the point of this is we can now write go ahead and do it.
Sorry, book.
Oh no. It'll never be the same. Oh, maybe it'll stay open now. No, not really. This is a good binding on that book, I can't tell you. Alright, so we want to integrate. Let's see here, we're integrating y. That's the 0th order term, right? And then plus what? 1/2 commutator of xy. Then what?
Plus 1/3.
Oh, yeah, 1/2 minus 1/6 is what? Yeah.
So we're not going to the third order now?
Not yet.
Okay.
I'm just going to do this much. Make myself feel better about my day. And then we'll go to the third order. That's 1/3 xx. Yeah, we'll come back to that probably. X. You say 1/3. 1/2 minus 1/6 is 1/3, eh?
Yeah.
At least in Canada. Let's see here. And then, okay, so then, oh, then you got,
Minus 1/6.
yeah, minus t over 6. Which, okay, fine. Yeah, yx. That's it. No, that's the y, isn't it?
Yeah, xy.
yxy.
So y is always at the end.
Right. And then other stuff. But that's all she wrote for nested. Just 2 commutators, right? And is that it? Am I not missing anything?
Mm.
Uh-huh. That is not looking good. Because this is x plus that. That should be equal to the log of e to the x, e to the y, right? And of course this is just x plus y plus 1/2 commutator of xy plus 1/3 x with xy. And then this integrates to give us minus 1/12 y with x and then with y again. I like the 1/12.
Right, we want the 1/12 on the other one too, right?
How is it that that has come to a third is the question. This is the conundrum. Now I said that the z minus 1 times 1/2 gives us x and y to second order, right? Well, that's the first order terms in that. But there's also second order terms in that, right?
Right.
I haven't included those yet. So what else am I missing at first, quote unquote, the first order? The organization of this calculation is a little bit unfamiliar, isn't it? Yeah.
1/2 at x squared.
Yeah. So this, I'm missing the,
Not that one,
not that one,
but that one.
that one.
Plus 1/4.
So that's xx.
Yeah.
Like that there. Anything else I'm missing? There.
I don't think so. Not the second
Not for
one.
second order.
I think that's it. So that gives us plus 1/2. What's a? Does it give us plus 1/2? Well, that's, excuse me, it's 1/2. That's a fourth, right?
Right.
You're telling me that already. Sorry. Because the 1/2 there times the 1/2 here gives me a fourth. What's a third? Third plus a If I had somehow to,
We want a third minus a fourth.
yeah, I want to, exactly, I want either, or I want a fourth minus a third, I'm not sure. Third minus a fourth, I like better. Should that be minus? Oh, I'm a doofus.
Oh, yeah. Oh.
Come on, look at this. Shouldn't that, oh, no.
No.
No, I want it to be minus, no, it's not. Is that minus? Is this a minus? Does it go minus plus? Better pin that. What, am I wrong?
Oh, for that in the first place.
That would serve me right, all that stuff I said about I like to work it out in general, I don't like to look at terms.
No, it starts out with plus. This is the way you wrote it there.
I think it's right.
Yeah, in the book it says that as well. One plus
so
1
1 plus 1/2 minus 1/6, alright. So let's see here, at the bottom of page 75, he's got y plus 1/2 commutator xy plus 1/4 xxy, which is what we got
Wait.
there.
Wait.
Yeah, you got
What you underline in purple, that was supposed to be the second order part of 1 z minus 1, but the second order part is just 1/4. Or, see,
I'm sorry, I'm not holding. You're right. So I can't.
kind of just like made a jump, but instead of like on the underline
Yeah,
part.
the way I'm presenting this calculation is not optimal. So that's not supposed to be there. I have included that in the next step. You're right, Daniel. That is here, but I'm missing my.
should it be 1/4 there?
Should be 1/4 there. Yes. Also true.
There we go, then we'll get 1/12.
Yeah.
The long desired 1/12.
So 1/4.
So we got 1/4 minus 1/6 is 1/12, so we're good.
And those are the only. And these two terms are the ones that are coming from the z minus 1 squared.
Yeah.
Yeah.
In particular, this guy and that guy.
This guy, that guy.
And that's it. Oh, then we get a quarter.
Minus the 6, which is 1/12.
Oh, okay, thank you. Yay! And of course, so if you exponentiate both sides, right? You got e to all this stuff is e to the x times e to the y,
Yeah.
which is what I like to call the Baker-Campbell-Hausdorff relation. All right. Now that's what he has.
Now, for third
Once
order.
more.
Yeah, let's find out what's past 12.
We're gonna do it on that board.
Or if we're gonna spend a whole semester just to try and understand this one little bit of math, we ought to at least get something beyond what's usually known. I think we can spend 10 minutes of our time on this, right? I may regret. Oh man.
It's like almost 5, right?
I was so hoping to talk to you guys about covering groups and the other stuff today, but
Well, this isn't drawing. Do we have 2 or 3 more lectures?
yeah, we have a couple more meetings. I don't think we're gonna do representation theory.
I was about to say I don't think we're ever gonna get
We
to
still
that.
plan on doing
Good
that
thing I'm writing a
makeup-
paper on
that
it.
makeup session.
What's that?
We still plan on doing that makeup session.
Oh yeah, we still need a makeup
Sunday.
session. That's true. But
On
no, I think what would be better for me to do in here, as opposed to like representation theory, is a long haul. That's like a semester's worth of work to do, right? So if I try to just kind of like, first of all, I want to leave like me not talking about it is better for you because you can just read and come up with a paper, and I won't, and I'm not taking away from you the low-hanging fruit.
Exactly.
So it's actually in your interest that I don't do it. I am planning, if everything goes as planned, we might do representation theory like next spring.
Next spring. Okay, that's a long ways away, but
Right.
I'll probably do it.
So by then you've had abstract 1,
Yeah.
and if you're not tired of listening to me jibber jabber about nonsense, then you might join us. But okay. So the next term, yes. What are we missing?
Okay.
What is beyond? So we can focus, right? Focus in on. What are we looking for?
All that best of z minus 1 cubed stuff.
Yeah. So like the third order stuff. What is that? third order in the commutators. I'm just going to focus on the third order stuff. We already found the second order stuff, right? That's part of what makes the Baker-Campbell-Hausdorff relation like manageable. Is you don't have to do. You can focus your. If you the point of it is the way to understand the expansion is to focus on a particular order of nested commutators. So you can divide and conquer in this way, like.
Yes.
All right, so third order. In the z minus 1 term,
Right. What is third order?
what's the best of z minus 1 is really my question.
It's at the end.
Not
that.
Not that, not that, not that, just that.
Yeah.
So 1/6, blah, blah, x, x. That's funny. I don't know why, but that one extra commutator makes it look so much worse.
It's true. It does.
It's weird, right? I mean, isn't that strange? It's just one more commutator, but it's just... Do I have an extra one, or no? That's really just... Yeah, okay.
It's kind of like spelling the word banana. You never know when to stop. Banana.
Or Mississippi, or... sometimes other words like definition, I'll find myself like halfway through it and be like...
Definition.
Yeah, or something like that. I'll do that kind of thing. Okay, z minus 1 squared. Best of third order.
1/2.
Ha. Yeah. Oh, that's another one of these guys, isn't it? Oh, but I should be careful. Not 1/2. What is it? 1/2 from this.
Which
And-
and 1/6. Or oh yeah, 1.
1/2 from that.
Huh?
Oh, wait a minute.
No, 1/2 from the 1/6
Oh.
you have up there, and then 1/6 from the.
Oh, so this is actually a 12th, isn't it?
Yes.
Don't let me get away with that. So I get, yeah, well, the 1/2 from this,
And
and
then
the
on
1/6 1/6 from that, that gives me the 12th. And then, you capturing all this, Bradley?
I mean,
if you're not where I'm pointing,
I'm
this
not
is
really.
pointless. So 1/2 from here, the 1/6 from here, that gives me the 1/12 from here. You're actually going to do some work, Mr. Cameraman.
So the 1/2
Get
from
together.
there, and then the 1/2 from point to the one below.
Here, I'll use some color coding. This 1/6 and this 1/2 go together to make that 1/12 in the third order term.
Yes.
Now, the
then
next,
you have 1/6 and negative 1/6. Right?
then the minus one. So yeah, I have this minus 1/6 with
The 1/2. There.
this one. Yeah, that gives me what?
Negative 1/12.
Oh.
They cancel.
Negative. It was. They cancel?
It looks like.
Oh, what?
They shouldn't cancel.
Well, I mean,
1/2.
if they do, they do,
Negative 1/6.
right?
I
mean,
guess
it
I
is-
do.
I mean, it is what it is. So.
Huh.
All right.
Okay.
Is there anything else in the z minus 1 squared?
Let's see.
That one,
There's
right?
Yeah, that.
So minus, what do we got here?
Minus 1/12.
minus t over 12, right?
But yeah, minus t over 12. And then you have commutator y of
So we go-
x of x of y.
Y, y,
Right.
x, y, right? Sorry, I'm tired.
Wait, no, it's
We're doing-
isn't it
the
y x
first one
x
is
y?
y x x y.
Oh no, where? What do you say first?
We're
Oh.
doing the one with the half add y add x squared.
That one.
Yeah, that one.
Oh, so it's two x's.
Yeah, y x x y.
Y, x, x. Okay, thank you, yes.
Yeah.
Yeah.
Okay, fine.
And then,
There should be 3 on the end. I know that.
Help me out. What's next?
and then the last one, minus 1/12 t squared.
Right, so that one. Right there.
What? Tell me my letters.
Y y
X.
y.
So that 1/2 times that 1
Is that
negative
it?
1/6 equals the negative
Stuff is so much fun.
T over 12 YY XY. I'm guiding
I'm narrating.
the future students
future
through.
viewers.
I'm
Now I have to
zooming
take this
in.
down and just make it a homework. Final exam in linear. All right.
Final exam for us.
I think that's it for a second.
Is that it?
That's it for
That's it for
squared.
the z minus 1 squared
Yeah.
at third order.
Mm-hmm.
Z minus 1 cubed at third order.
I think looks like the all. Oh, right.
All of them?
Those were the
Oh,
ones
we just
wrote,
kept the
yeah.
ones that matter, right? And then we got to be careful. The coefficient is 1/12. You got like plus 1/12,
1/12 from up there
and you got yourself xxx,
times x. So we get 1/12 xxxy.
and then this gives me
Then
plus t over 12
Second one,
xy.
t over 12. xy. Then the third one will give you
T over 12.
t over 12 yxxy. Okay, and then the last one will give you t squared over 12 yxy.
Should have done this with a and b instead of x and y. X and y are so annoying to write.
Sure.
You don't have to do your
They're hard to look at too.
You don't have to
Well.
do your dashes on the top and all that. You just
Yeah, no, I'll just leave them like that. But is anything combined here? I mean, of course, this
That's 0.
0, but
The y, x, y's look like they cancel on the end of each line.
okay. I guess what I'm saying is look for where else do we have like x with xy anywhere else?
yes. Oh, those
With a
cancel
y
too.
with a y in the start.
Yeah, the second to last on both
Oh,
lines.
this one right here is another one of those, right?
Yeah, they cancel.
Do those? Oh, they do cancel.
So do the last ones on each line also cancel. The t
Oh,
squared
yeah?
over 12 negative t squared over 12.
Oh, cool.
That cancels. So we get just those two.
Interesting. So we have to integrate these, right, from 0 to 1,
Right.
and they give us the terms 1/12 commutator of x. Is it 1/12 again, really? X. And that is integrating to give me 1/24th, right?
XY.
That feels wrong to me.
Yeah. I don't see anything wrong with it.
This is most certainly wrong. I don't know why, though.
Oh.
Oh.
Oh, wait. No, it's good too.
Are you gonna look up what it actually is?
Let me try.
Gonna have to blur out the Ted Cruz logo on the tape. when you
So
watch
what,
the
for
camera.
future purposes, after he's forgotten, put on the waistband,
for,
waistband of political history.
For equal time purposes.
Oh, for equal. I'll feel the burn.
I'll feel my heartburn while making America great again and going
Oh.
to the FBI and.
You- I'll tell you what, that 60-minute story about how hackers can actually not just hack who you've called, but they can actually hack conversations, given the way the network is set up. From I'm not sure.
Oh, so it's not just metadata?
No, it's not. Just
That's what they've been
metadata.
telling us this whole time. That's why
Yeah.
it's okay.
Oh well, surprise, surprise! The government was lying to you. Let's see here. No, it wasn't the government. It's just that there's convenient weaknesses in the network which hackers can exploit. which of course has nothing to do with like a weakness that the government would put there on purpose so that they could exploit against citizens or anything like that.
Well, if the iPhone is not
that?
safe, then nothing is safe.
Oh no, I'm saying this on YouTube. People will hear me. Where was I? Oh yes. Baker.
Talking about ice cream with their clothes off earlier, so I mean.
On Earth. Oh, yeah, come on. I had it, and then it went away. How about Wikipedia? Don't let us down.
Zoom in on the screen.
You're zooming in. Don't zoom in on. Oh my goodness. All right. Allegedly, it is 1/12 xxy plus yyx. If we switch the order in that one, it becomes
Right,
yyx.
right.
So we got that one right. The next term, allegedly, is minus 1/24 yxxy.
YXXY?
Y.
But all our y-axis is y is cancelled.
Minus 1/24 yxxy.
Oh no.
And that's it for that order. The next one is yyyx plus xxxxy, and then plus 1/360 x yyyx plus yxxxy plus 1/120 yxyxy plus xyxyx. Oh
Yeah,
man.
that's pretty blurry.
So allegedly, the next term is just 1/24. Oh, it's pretty. Are you actually trying to zoom in on that?
I actually am. Oh,
Okay, well, if you're gonna do that,
yeah. Oh, that's much better.
yeah. So we're missing. We should get this if we trust the Wikipedia.
Just negative 1/24
But
yxxy. Huh. Yeah, I don't know what we're wrong.
Man, we're not too far off from that.
So, I mean, we don't even have that term in our thing, and we have two others.
Hmm. Well, the Zassenhaus formula.
That sounds amazing. Is that just more terms? Is that...
It's a different way of writing combinatorial. A related combinatoric expansion that is useful in dual applications is this. The Zassenhaus formula. Interesting. Yeah, well. Hey, check it out. I think we just found your test.
Did we do... Oh my gosh. Did we do the third orders of the z-1 and the z-1 squared thing?
Yeah.
We did? Did we...
Those are the first ones, I think.
What about... Is there anything that comes from the 0 degree? I guess not.
I'm actually pretty happy about this because now we have a test for you guys.
I'm not sure if I want that test.
So the test is to explain, well, either to confirm or deny Wikipedia on the nested commutator case. Wait a minute. Nested. Yeah, nested. It's not a nest. There's two nestings.
Third order is two nestings.
Yeah. Because it's a commutator of a commutator
That?
of a commutator. When is that
With
three?
all that.
Depends on what you mean by nested.
Yeah.
Like you'd only start.
Anyway, it's something like that, but we missed something. Sign. Or we had an improper cancellation, like...
Maybe we should do it, but we should just evaluate all the commutators out.
No.
No. It's the worst idea.
Oh, you mean just write it, just foil it out like
X, Y minus
just straight
Y,
from the
X.
definition?
Yeah.
No, that is not an allowed solution. Your solution to the test must be done in the language of joints.
And it's for the better.
Yeah.
Well, I guess this is a take-home test since we already know what the...
Yeah, this definitely a take-home test. The other aspects of your test I will have to think about, but that much we can say.
Start working on that.
Let's see, what else do I want you guys to do and I have to do myself? I make that test, right? I've been making tests for undergraduates to check what they already know, but what I should have been doing all the time is using tests to make undergraduates do calculations that I don't feel like doing. We're doing it all wrong, man. The trouble is I like to do most calculations, so it doesn't really work. Alrighty, well, if you haven't already turned it off, turn it off.